Okay, we're talking geometry, and we are living in the formula sheet that they give us. The top part of the formula sheet is geometry. The bottom part is, did I say geometry? Is algebra and data and stuff like this. Pythagorean theorem is hidden down here as algebra, although that's about triangles. Right triangles really is kind of more of a geometry thing, but whatever, it's down here in algebra. So here they are. Two-dimensional shapes, stuff you can draw on a piece of paper, are here and here. Three-dimensional shapes, stuff that exists in time and place in 3 dimensions, are down here. We're going to be talking mostly about area and perimeter. Now, let's look at the information they give us. It is almost helpful. A means area. Let me get my disappearing ink pen, my fancy disappearing. So area, that's A. Square, it's S to the second power, or S times X. That's L times W, B times H, B times H, H times B plus B1 plus B2, and that's pi, and that's radius, or whatever. They don't say what any of these things mean. Now, this means side, this means length and width, this means base and height, and this means 3.14, and that means radius. But we have to, as always, get to know how the question is going to be written. So we're going to deconstruct this a little bit, and I'm going to slide over to where I got some blank screen.
To the left.
So first shape that we're going to do, let's go red. And I have a couple videos already that do this. The first shape that we're going to do is parallelogram. And then down here, I'm going to do the much easier to draw rectangle. And then over here, I'm going to do that looks about like a square. All right, so if we do our terms really quickly and really, really quickly. Oh, I forgot to do one thing. There we go. So polygons are shapes. Any shape is a polygon as long as the line meets and, there's an inside and there's an outside. Quadrilaterals are polygons that have 4 sides. So quad, 4, lateral, line. Parallelograms are lines where the opposite sides are parallel and they will never touch, like train tracks. Those two things will never ever touch. So that side and that side, actually I should do it right, where that gets a double. So single arrow and single arrow lines will never touch. They go on forever, all the way to India, back through Europe, all the way back. They'll never ever touch each other, and neither will those double arrow lines. So that makes it a parallelogram. Let me get rid of those. So polygon, quadrilateral, parallelogram. Now, a rectangle is a polygon, a quadrilateral, a parallelogram, and what makes it a rectangle is that all of the angles are right angles. They're exactly left, right, up, down. There's no leaning one side or the other. Now, they can tilt it and all that stuff, but they meet at an exact angle like that. If you can see the way my face is shaped, because I got a box for a head, like a shoebox. So that is makes it polygon first, quadrilateral second, parallelogram, rectangle. A square is a polygon because it's closed in, quadrilateral because there's 4 sides, parallelogram because the opposite sides will never touch, rectangle because everything's a right angle. Square means all the lengths are the same side. So if that's 7, that's 7, that's 7, that's 7. Odds of there being a question about those terms on the test is actually probably 50-50. Just know quadrilateral means 4. Parallelogram doesn't specifically only mean this shape, because this is a parallelogram also, because that's parallel and that's parallel, and so is a square. But just vaguely know, just be aware that those words may mean something and they have specific things. So there's the classic, all squares are rectangles, but not all rectangles are squares, whatever. A square is the most defined of all of them. All of that you may never need to know. We are talking solely about area first. So here's what I'm going to do. I'm going to change my pen color to blue, and I'm going to start writing down numbers. This dotted line and that little square thing right there is huge. If they're giving you that thing, that invisible line, it's because they have to. More than likely, 99% of the time, they have to. So let's say that imaginary line is, you can't see that again. Let's change it to yellow. If that's 5, and let's say this line is 8, and they're not even close, obviously by scale, and they gave us this line. And then I'm going to call this line 8, even though it's longer or whatever. And then I'm going to call this line 5, and I'm going to call this line 10. Geometry is either really long word problems where they bury the numbers, or a drawing or not, and tiny bits of information, and then just the simplest of instructions. So it doesn't matter. It's like Scooby-Doo. They're always going to give you enough clues to solve the problem, and you find out it's the caretaker of the amusement park that was pretending to be a ghost all along. If we want to know the area of this space, this whole inside here space, regardless of what the formula says, the formula says what I'm about to do is the same thing. Look for this. Wherever there is a that, an up, down, and a left, right, even if they twist it a little bit or whatever, multiply those two numbers, and that is the area inside. This number does not directly help you solve that problem. So that fatigue and distract thing that standardized tests do, they may give you this number, and it may make you think you got to use it. But if we place importance on this, that symbol, and we go, thank you for telling me. That's the area we care about, is where those lines meet. Now I'm going to go down to rectangle. They may not give that symbol there. They may merely call it a rectangle. The definition of rectangle means that they do meet at right angles. So it may not be there. But if they say rectangle, that's their lawyer talking. And we got to say that there's enough clue in there, Scooby-Doo style, that we multiply those two numbers, and that'll be 40. Now square, the sides are all the same. The angles are all right angles, so they are implied that they do that. This is the grass, and this is the building. It's exactly up, down, left, right, even though I didn't draw very well. So if they say square, they don't have to say right angle, but we can get it. Rubik's Cube style, whatever, it's a square. If that's 10, this is 10. If we want to know the area, multiply those two numbers. So look what I'm doing here. It's where the right angle is. Whatever makes up that right angle, multiply those two things.
Hey, Jeff, can I ask you a question?
Anything, my brother. What's up?
Hey, you said you're talking about the right angle, but you're putting the right angle on the left side of the problem.
I love you. So yeah, right just means 90 degrees. I should define my terms. Just means 90 degrees. So if they if they described, well, later on when they do triangles, they'll talk about like a ladder against a building. So I'm going to hold on to that. But anyway, yeah, this is a right angle. That's a right angle. Right just means exactly up, down, and left, right. I'm not going to hand draw that one, but you know what I mean.
Okay.
So, and they'll turn these things sideways. So if you see, we're doing the same thing. Find this, whether they say it through the definition, saying it's a square or a rectangle, or they actually give you a dotted line. Find those two numbers, multiply them, and you'll get the area. So this is 100, this is 40, and this is 40. Now, how do these things, even though I didn't draw them to scale, how are they the same? Let's say I did. And this is how. If you break off this triangle spot and put it over here, then you just made a rectangle. And that's why they're the same. So if you can get this, if we did a handout right now and did here's all squares, parallelograms, rectangles, and all that, find the area. You could find this out. using a calculator if you want, you could get the right answer in 5 seconds. So we just did 3 formulas without mentioning the formula. Now the formula for square, I'm going to do square here, and I'm going to do rectangle, and I'm going to do parallelogram. We'll go back to the sheet. This one says A equals side squared. And it's right. It's right. This is a side. Squared or to the second power means it's a repeater. That's how many times we write it. It tells us to write it 2, so 10 times 10 is 100. That formula is specific to square. Rectangle, it'll say length times width. Now, which is length and width is which? Which is width. It doesn't matter. If you take the lid of a shoebox and hold it this way, and then turn it that way, it doesn't matter. One's length, one's width, but length has the connotation of being the longer side. It doesn't have to be. Because when you multiply, you could flip the numbers. 3 times 2 and 2 times 3 both equal 6. So it doesn't matter. So length, let's just say, okay, I'm going to call this the length, and I'm going to call this the width. We just multiply them, and this is specific to rectangles. For parallelograms, it's going to say A equals BH. B stands for the base, and H stands for the height, which is that dotted line. It's where that meets. It's where this meets. It's where this meets. They're all the same thing. The formulas are specific to a shape, but the function is universal. The only difference, trapezoids and rhombuses, rhomboids, rhombi are slightly different. They're a little bit of a tweak, but for the ones that we're going to use the most, it's up, down times left, right. Now, I am not replacing the formula because here's what GED does, and the Tabe test. Not the Tabe test, I'm not teaching to the test, but Tabe does the same thing that GED does. If they wrote a parallelogram this way, and they gave us some numbers to work with, and they said 7, 5, 4, and we go, okay, it's parallelogram, I get that. And we go over to it, and it goes, oh, thanks, Carol. If they said base times height, it sure looks like that's height, right? And it looks like if they gave this as a 5, it looks like base means bottom, doesn't it? Isn't that what base is supposed to mean?
So it's supposed to mean.
That, and then 35 would be one of the choices. But by rotating the thing, this is technically the height, and this is technically the base.
So you multiply those two numbers, Jeff?
The up, down, and left, right. So these terms are then sort of neutralized for being helpful. They don't define what they are on the formula sheet. Where'd the formula sheet go? Oh, it's here.
It disappeared. Oh. No.
It's over here on the side. Oh, this is going to kick me out. Don't do that. I'll have to do this again. But A equals BH doesn't really help if they turn the thing. You know what I'm saying? If they had laid the parallelogram on its side like this, if they had done this and then did this business, hold on a second. Get out of here. So there's the base times height right there. I want to move over, and it's going to keep me up. There we go. Perfect. Then it would sure look like this is the base. And for some reason, since height goes up, we think that way, that's the height. And we would end up multiplying these two numbers. This dotted line is the height. So that's why I'm saying this is the clue. That's the Scooby-Doo clue right there, is anytime there's a square. So when I go back through all this gigantic mess, formula sheet helps. It doesn't define what the terms are, but the learning that does, the conceptual learning behind all of this, is that four-sided shapes, quadrilaterals, are measured for area, up, down, times, left, right, and ignore that number. Up, down, times, left, right. Up, down, times, left, right. Whether they give you the signal or not. How much is this going to help us? Well, first of all, a whole bunch of stuff should click into place. And that way we're not memorizing one thing for one thing and then they twist it and suddenly what's the base? What's the height? Because just because you rotated the piece of paper and asked the question sideways, I'm lost. We don't want to be mechanical about this because memorization is the lowest form of learning. We want to be critical thinkers and go, I see the common thing here. So that's our clue. Anytime we see an up, down, left, right, or something described as a flat line, or here's grass and here's a building, we're going to assume that's up, down, left, right.
Yeah, that's actually what it reminded me of.
Yeah. Oh,
Up,
and
down, left, right.
when they do the word problems, that's what's going to be, because they're going to do a ladder leaning on a thing, and that's going to make a triangle. So maybe on that video, in that little break there, maybe I put in some worksheets where it's a bunch of four-sided creatures or whatever. Rhombus, trapezoid, we do later. But we want to go parallelogram, all that stuff. So here's my square. If this side was 10 and it's a square, that means this side would have to be 10. So that's something they'll not give us. If they call it a square, they'll only give us one side. Or, they can, and we would just have to know. So we just covered, if it's an up, down times a left, right, or side times side, or whatever we want to do, or side squared, 10 times 10 is 100. Now, if I cut the thing in half that way, perfectly in half, that side would be 50, that side would be 50. If I cut the thing in half this way, this side would be 50 and this side would be 50. If I cut it in half peanut butter jelly style, then this side would be 50 and this side would be 50. So the question is, if I had a triangle and this was 10 and this was 10, how do we find the area of the triangle? Well, we look at what we just did. We multiplied left, up, down times left, right, and then we cut it in half. Divide down, and that gives you 50. If we don't cut it in half, we'll get too much, exactly twice as much, because we'll get the other half of the sandwich. But we only were doing the one triangle half. You got to split the sandwich with your brother. So that is how the area of all triangles can be found. You find the up, down, and the left, right, someplace where there's some sort of right angle. Multiply those two numbers and cut them in half. Now that is slightly different, not different, but just in a different order than what's given on the formula sheet. Obviously the formula sheet is right, and it writes it this way. Area of a triangle is 1/2 BH. And we got to know that there's some times dots in there. That's 1/2 times the base, and then times the height. If you look at that, and the thing is written askew or slanted or rotated or whatever, where it's not clear which one's the base and which one's the height and all that stuff that can happen, like we said before about the parallelograms, they can mess with our heads that way, and we want to protect our heads. So the function that we did in order went find the up, down times the left, right, multiply them on the old calculator, because you get to use a calculator for these, and then divide by 2. That is the same thing as the formula, how it's written, except you don't have to deal with fractions. It does the same exact thing. Multiplying by 1/2 is the same thing as dividing by 2, which is no great discovery in math, but we want the least amount of friction on this test as possible. And that is obviously fine in the standard and use it and all that stuff. But you know GED and standardized tests are going to ask things slightly sideways. So if we cleared all this stuff out and we went to the formula sheet, wherever it is, it's over here. Come here, formula sheet. We covered the area of the top part of the formula sheet as soon as it shows up. And we can, as soon as it shows up, we can see how all of the formulas are generally not the same thing, but they all function off the same dynamic. That there is somewhere, there has to be supplied or whatever. Oh, we can't see yellow now, so we gotta make it blue. There is an up, down, and a left, right. Even if they write it like this, that up, down, and that left, right is the most important key. So that dotted line stuff and all that, when they have to give that piece of information, man, is it important, because it does this one, this one, this one, this one. And trapezoids are shaped like this, where it's sort of uneven, the two bases. So it's sort of the same, but it's a jacked up looking rectangle where only two lines are parallel. And if we had to deal with that, this is the height. The dotted line would be the height. Or if it was a right one and it was like a perfect, that's bad handwriting right there. If this was that, then this would be the height. And it says B1 and B2. This is base 1 and this is base 2, which sounds like Space 1999 with Moonbase Alpha. If you remember that show, it was on Sunday nights back in the 70s.
I remember Lost in Space.
There you go. Danger, danger. So height would be that one. And it doesn't matter which one's base 1 and base 2, because you're just going to add them together and then multiply it by the height and then cut them in half. That's its own little weirdo. But other than that, we just covered all this. We didn't do circle. Let's cover perimeter in 10 seconds. There are all these formulas. Add up the sides. Pretend you're putting up a perimeter fence. Add up all the outside sides. Now, there's obviously clear ways they can ask that stuff and unclear ways they can ask that stuff. However, that's all perimeter is. It's walking around. Area is inside. Remember, everybody's trying to break into Area 51? They were trying to get inside Area 51, but they were kept out by a perimeter fence. I need more coffee.